Now I'm going to share. All right, so now I'm going to show you yet another interesting tool. So I started talking about regression trees, and I showed you how to do that in Weka with like the default ones. But there is like a super regression tree, okay? Like the best, state of the art, okay? I'll share the paper with you guys so you can read about it. It's called XGBoost, okay? It's a boosting regression tree, and there's a whole bunch of things. We'll cover that in the lecture part of this. So that one we have to code. So we're gonna go back to our Jupyter notebook, right? And use that one. So I'll show you how to use it. And that would be basically, as far as I know, the last thing I would throw at this problem. Okay, I've thrown PyTorch already. I threw Weka at it. And the last thing I would do is I would throw XGBoost at it. And with that, that's the best I can do. Okay. And then hopefully some of you, because your homework is still to build a PyTorch model, right? That is as good as possible. So hopefully one of you will be able to, get even better results. Maybe. It's not, that's the fun of the project, right? Okay, so we're gonna go to our Jupyter notebook, right? I'm gonna start with just an example called the Boston dataset. It's a regression dataset. I'll kind of illustrate how that works. And then after that, we're gonna run our dataset on it. And that will be it for class today, okay? It's the last thing. And again, what do we want to determine? The R squared. XGBoost, now I actually didn't test this one because I wanted to do it in class, right? So I honestly don't know if XGBoost will be better, right? But by looking at Weka, I know that a random forest did well, right? Apparently. XGBoost is supposed to be the best regression tree model available. So maybe we'll get even a little bit higher than 0.54. It's not guaranteed, obviously, but it's something to hope, right? So yeah, so let's go ahead and do that. So I'm going to start. This we'll do in the Jupyter notebook as we normally do, because it's a Python library that you need to install. Okay, I already installed it on my computer. For some reason, the first time I tried it, it gave me an error, but the second time it worked. So, just be aware of that. All right, so we should be recording, I think. So let's go ahead. All right, so let's do conda environment list. Right, and then you guys are section 2, so conda activate pi 37 TS 520, and you guys are section 2. Okay, all right, so then let's go ahead. All right, so like I said, I'm first just going to do a generic example of XGBoost, and then we're going to do the actual wine quality example. And I'm doing these as separate Jupyter notebooks, okay? So you can handle this however you want. So the key is to install, we already have scikit-learn, which is what we're going to need for the Boston data, I believe. And we need to install XGBoost. So that should be. Oh, let's also navigate to our folder. So you guys are section 2. And I'm going to go into regression because this is regression related. Yeah, and that on title is actually my example that I was doing. Okay, so let's go ahead now. You guys can do this on the Jupyter or you can do it here. I already did this but you would type pip install XGBoost, okay? XGBoost, like that. So go ahead and hit enter and let me know if it lets you install it, please. Is it installing for all of you, or is it, okay, good. Yeah, so just, it shouldn't take that long. Okay, let it install. Once it installs, it's a very complex library, okay? It's a very complex tool, so we'll talk about how it works later, and as I said, I will share the paper also so you guys can take a look. But it's easy to use. It's one of those things that is quite complex to implement and yet super easy to use. So that's the great thing about it. Now, as I said, it's supposed to be the best regression model. How do we know that? Because in a lot of competitions, if you go to Kaggle and so on, you will see that for, once again, I'll repeat, not for NLP or for image generation, right? But for tabular data, which usually means when you're trying to predict a regression value like wine quality, given a few features and not such a large data set, right? XGBoost seems to always do really well, even better than like machine, deep learning and so on, okay? It's just experimentally, it has been observed. All right, so let's go ahead, and I've observed this myself also. Now, it does have a drawback, and remind me to tell you what one possible problem with it might be, okay? But let's go ahead and start. So we've installed it, it seems. Nobody got an error or anything like that. So let's go ahead and run Jupyter Notebook. Okay. And hopefully it won't take that long to run. It shouldn't be that much code. We're going to need the, sklearn is really the tool that we're going to be using alongside. So I already created this. Just create a new, go to new Python 3. And then I already created it here. Okay, so basically what you do is you import XGBoost as XGB. Then from sklearn, we're going to do a couple of things. So from sklearn dot datasets, we are going to import load Boston, and that's just like a standard regression data set that we're going to play with. Okay, we may also need train test split, so let's go ahead and do that one as well. From sklearn dot model selection. Yeah, zoom in. Okay. Yeah. From sklearn dot model selection, import train test split. Okay. Split. And then, there's another metric called the mean squared error, but really, we haven't been using it and it doesn't really give us that much data, but the R square is the metric we have been using, right? Now I have calibrated this R square, and it's pretty much the same as, the R square that we get here with XGBoost is comparable to the R square we're getting with our PyTorch model. So it's consistent is what I'm trying to say. So I already checked for that. So from sklearn dot metrics, we're going to import, of course, our same R square score, right? Which is what we used in our other code, okay? Okay, that should be everything that we need. Oh, pandas. We're going to need pandas. Yeah, we're going to need pandas also, but we've used pandas before. So let's do import pandas as PD. So we're going to read in a data frame, basically. Everyone with me, guys? Okay, great. So let's go ahead then, and hopefully it'll work. Cross your fingers. Okay. So everything should load with no errors. Okay, good. And then once you have those, we're going to, okay, so it did it for me too. Now we're going to load the Boston data set. It's like the wine quality data set, same idea, okay? So I'm going to just say Boston and load underscore Boston, right? Like that, right? And any questions? And then we're going to use pandas to create X and Y, which I think it's consistent with how we did it for the wine quality data. So you can pretty much, plug and play, if you will, right? It should be very consistent. So now invoke PD dot data frame. Like that. And we can load Boston as our data set. So just say Boston dot data, comma, and the columns are going to be equal to Boston dot feature names, okay? Feature names. Got it? All right, so that should be our X data there. And then we're going to load our Y data, also PD dot series. And we're going to say Boston dot target. Okay. Got it? Everyone with? You don't see? Okay, so can you see now? All right, so that's our data. Go ahead and run it. It might give us a warning, but I believe it works. Let me rename this, actually. I'm going to call it XGBoost Boston. Okay. And I'll load this on the GitHub later. All right, so go ahead and hit run. Yeah, it gives me that, but it's only a warning. It's not an error. I'm going to run it again. Usually when you run it the second time, the thing goes away. Got it? Everyone with me? Any questions? All right, good. All right, so the next thing is we're going to look at the data. So you can do x dot head. X dot head. Click run. And there you go. It's a standard pandas data frame. I don't know if it's about, this is the Boston Marathon. Could be. Not sure. Okay, some data. Okay. So now let's take our, we're going to use train test split just to split the data. Okay, so just like we've done before. So I'm going to do X train, X test, Y train, Y test. Okay, and I'm going to call train test split. Train test split. I'm going to give to it X comma Y. And I'm going to hit run. All right, so I've split my 4 data sets as we usually do. And now comes the XGBoost part. We're going to initialize the XGBoost model. It's a regression model. So sometimes people call them regressors. So that's the name of the object, regressor. But it's going to be X, and this is where the library comes in, XGB dot XGB regressor. Okay, that's XGBoost, the instantiation of it, basically. And we can provide a few parameters, just kind of default parameters is fine in this example. So let's do n estimators equal 100, comma, and then some parameters. So you can just use defaults for this. So reg lambda equal 1, gamma equals 0, and max depth, which is the depth of the tree. You can play with that parameter if you'd like, but just leave it at default, I would recommend, equal 3. Okay, so we're creating this default regression model. Okay, go ahead and load it. All right, it's loaded. Add a few more cells. Now, let's go ahead and fit the data for this regression model. All right, we're going to train it, basically. So invoke regressor dot fit and give to it xtrain, comma, y train. Does that make sense, guys? With the Boston data set. Go ahead and hit run. I don't believe it takes that long to do. It's already trained. These are just kind of the parameters that it used. Just, you know, these are all the built-in parameters of it. Okay. And now let's predict. So I'm going to do ypred equal regressor dot predict on X test, correct? Everyone with me? So we're going to predict on X test, run, there it is. You can print out ypred now. This is the Boston data, so remember we indicated that we wanted y to be the parameters, right? So we can take a look at those, which are in y test, right? If this is ypred, we want to compare these to y test. So we may want to print those out if you would like. Right? Yeah. And they seem to look similar, right? Okay, so what's the last step? If we have ypred and y test, we should be able to compute what? The R square, right? Remember, that's the metric that we want. So how do we do that? R square score, right? Oops, sorry. R square score, and we plug in here y test, y pred. And now for the Boston data, we're going to run it, and we get 0.91 R squared. Does this make sense, guys? This is XGBoost. See how easy it is to use? And this is like a very powerful algorithm for, again, I'll repeat, for tabular data. This is not for like ChatGPT problems, right? Yeah, go ahead, please. Yeah, sure. Which one, sorry? Oh, here, this one? Yeah. And I'm recording this, right? So I'll post this video. Okay, everyone clear on this one? So we've got about 28 minutes, right? Oh, that's half an hour. So the last thing we're going to do today is what? As you might imagine, we're going to now the moment of truth, right? I didn't run this myself, like I said, because I just wanted to see, create suspense, I guess. We're going to run it now with the wine quality data and see what we get. Got it? Well, that's the idea. You guys can help me out. In fact, go ahead and start coding it before me, right? And see if you can do it. You should be able to adapt this. And tell me, even, if you get to the R square before me, please let me know what it is. Now, in the previous one, when we used Weka, we saw that we possibly could achieve an R square of 1.54, right? 0.54. So if all my reading of XGBoost is correct, right, and my experiments that I've done before, we could get an R square of 0.6, maybe. That's really nice, okay? With only one drawback that XGBoost has, which we will talk about, but it's not always a problem. It's just in certain situations, that's the drawback, okay? All right, so anyway, did you get the notes? All right, so this concludes the example of coding XGBoost in Python with the Boston dataset, all right? And so that's the basic pipeline. As you can see, it's pretty straightforward. Now I'm going to pause this video and then I'm going to create a new one. And then it's going to be like a second exercise using our wine quality dataset. Got it? So I'll load that as a third video. All right, before I stop with this, are there any questions on this one? All right, no questions. So I'm going to go ahead and